Today we're going to look at the text and we have a lab sheet today. You're going to get a digital copy of this for your digital interactive notebook, and you're going to interact with it the way I do, but you're going to use lines in Google Slides to do what I do. Okay, let's look at the problem. This is 1.3, adding and subtracting fractions. Now remember, boys and girls, we're not adding and subtracting fractions for the first time. You should have a foundational skill in adding and subtracting fractions from 4th and 5th grade. In 6th grade, you're learning how to reason with fractions in a different way. Last lesson, you estimated. In this lesson, you're going to add and subtract, and you're also going to write number sentences. So we're going to put those two concepts together. Let's read the problem. When Tupelo Township was founded, the land was divided into sections that could be farmed. Each section is a square that is 1 mile long on each side. In other words, each section is 1 square mile of land. There are 640 acres of land in 1 square mile section. And here's an aerial picture of an example of a 1 mile by 1 mile square land. Over time, the owners of the sections have bought and sold land, so each section is owned by several owners. You can use number sentences to find how much land each owner has. If a farmer owns 2 acres of land and buys another 1.5 acres of land, she will have 2 plus 1.5, or 3.5 acres of land. The number sentence that shows this relationship is 2 plus 1.5 equals 3.5. The sum of the parts is the total land the farmer owns, 3.5 acres. If a farmer has 2.5 acres and then sells half of an acre of land, she will now own 2.5 minus half, or 2 acres of land. The number sentence that shows this relationship is 2.5 minus half equals 2. Now this is something that should look familiar to you, but we're going to use the skill to answer some questions. Let's go to the next problem. The problem requires you to add and subtract fractions to find exact answers. Remember to estimate to make sure that your answers are reasonable. As you work, use what you know about fractions and finding equivalent fractions. You're going to write number sentences to communicate your strategy for solving the problem. So this diagram over here, this green one, titled section 18 and 19, shows 2 sections of land that are adjacent or side by side, and it's in Tupelo Township. Several people share ownership of each section, and the last names are in each of the sections. The diagram shows the part of each section that each person owns. So the question down here, who owns the most land in section 18 and who owns the most land in section 19? Just by looking at it, you could see who doesn't own a lot of land, but it is questionable here in 19, who's bigger, Foley or Walker? And then in 18, Wong and Krebs and Fitz and Fuentes definitely have smaller lands than Lapp, Stewart, and Gardea. So, but we need to know exactly how much. So we're going to try to answer that question by manipulating the model and using what we already know about fractions. Question A. What fraction of a section does each person own? Explain how you know. Okay, here's our first problem. Problem A. What fraction of a section does each person own? I'm right here. Explain how you know. They're referring to this image. They want to know what fraction of the land does each person own. So I isolated problem A, and now we're just looking at the map. The question is, what fraction of a section does each person own? Explain how you know. This looks tricky, but it's actually quite simple. You want to create like a common shape that everyone has, or a common denominator, and you're going to section it off equally. So let me show you what I mean. In order to compare the size of everyone's land, they need to have the same denominator, or they have to have the same fraction that's being compared. And the way you do that is to section them off equally. So let me show you what I mean by doing that. So here I see half, and then I see this looks like this is 1/4 of the whole thing. What else do I see? I see that this is like 1/4 of this whole thing. So I'm going to try to stretch out the lines to even it out. I want to create a common denominator, which means I want to make sure that I'm comparing them to the same same size. All right, so what I'm doing is I'm imagining, oops, that each of these are number lines and I'm stretching them out. Okay, so I colored everyone's property lines. I'm gonna be creating equal sections throughout this entire land. Okay, so I extended all of the lines. And as you can see, some of them are smaller than the others. So what I need to do is get them to the smallest denominator, which is this size. So when I'm looking at this one, it looks like this is in half. It will be equal to the smallest denominator. I'm going to go this way. Same with this one. So now they're equal, but I have to do the same thing to the rest. Now this is a little wider than this one was, but I believe these are thirds. So I'm going to divide this into thirds, and this is half. So I'm going to divide this in half. I'm going to divide this in half. I'm going to divide this in half and that in half, and all of them will be equal. Okay, so I extended all of the lines. And as you can see, some of them are smaller than the others. So what I need to do is get them to the smallest denominator, which is this size. So when I'm looking at this one, it looks like this is in half. It will be equal to the smallest denominator. I'm going to go this way. Same with this one. So now they're equal, but I have to do the same thing to the rest. Now this is a little wider than this one was, but I believe these are thirds. So I'm going to divide this into thirds, and this is half. So I'm going to divide this in half. I'm going to divide this in half. I'm going to divide this in half and that in half, and all of them will be equal to the smallest denominator. Okay, so now when I look at the plot, all of the sections are equal, and now I can compare how much Walker has than Berg, or how much Wong has than Krebs. So if I count each of these sections, I sectioned off each section into equal parts. So each of these are equal. Now I can compare their fraction. So I'm going to cover section 19. Let's work with one section. It's an 8 by 8. And if I were to count each of these little squares or sections, it would equal 64. So there are 64 sections in section 18. So I'm going to write that down. There are 64 sections in section 18. This person's name is Lap. So how much does Lap have? The question is, what fraction of a section does each person own, and explain. Now this is section 18. We're talking about section 18. How much does each person own in section 18? There are 64 sections in section 18. what fraction of a section does each person own in this section? So let's isolate this section. So Lap, out of 64 sections, he has, or they have, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16. 16 64ths of one section. Okay, so that's part of a whole. Let's write that down. Part of a whole. Section 18 is one whole. And Lap has a part of it, which is only 16 64ths. Yes, we can simplify it, but let's keep it this way for now. Bach, this person, and I'm sorry that it's not this person. I'm going to spell the name because I don't know how to say it, but Bach. Bach out of 64 whole, 64, the whole. They have 1, 2, 3, 4 64ths of section 18. Now I'm sorry that it's blurry. And now let's try to answer the question. What fraction of a section does each person own? And we have to do section 18 first. Okay. So in section 18, okay, so I transferred my scratch paper information to my paper here. I have to do the same thing for section 19. Okay, so I do want to make a correction. This simplification is wrong, is incorrect. It's supposed to be 3:30 seconds. So I made a correction there. All right, so now it's your turn to do section 19, and you're going to do the same thing. And here is a picture of, you can pause here and use this information to answer your question for section 19.